Hello today, guys. So we're going to be talking about two different types of waves that exist. One's called the transverse wave, so you could title it up that, and the other is called a longitudinal wave. Okay, so that's on the other side of the board. You can pause right now and copy down what I have here. One sec though. This is a picture of a transverse wave in a slinky. All right, so you've seen that video of a transverse wave in a slinky. I don't know how good my drawing is. Yours is hopefully better, but it gets the point across. And then there's some words here you could copy down as well and put your date on the page too. Okay, so I'll pause right now and you could copy it down. Unpause. Okay, so a transverse wave, all right, in a slinky makes this up and down shape with what we've been talking about, crests and troughs. All right, those two parts of a wave. And it's defined by each coil on the slinky. If you were to mark a coil, that coil is going to move up and down. And that's what this arrow indicates, okay? But the wave is going to move left to right while the coil moves up and down. So each particle or each piece of the medium, which is the slinky coils, is going to move perpendicular to the direction of the wave, okay? So the wave is saying, I'm going to transfer energy that you use with your arm to shake the slinky from left to right, but the slinky coils are going to move perpendicular to that, up and down. You could write that down, that the particles move perpendicular to the wave, okay? So, some examples of that are water waves make this sort of shape. Each water molecule is going to go up and down while the wave moves left to right, okay? So in order to make a transverse wave, you actually have to move, say you have like a boogie board or something, you have to move it up and down, and it's going to send the wave perpendicular out from you through the water. It's the same thing with a slinky. If you shake your hand up and down, the wave is going to go in that direction, perpendicular to the way you're shaking. Perpendicular means at a 90-degree angle. Another cool example of this is the stadium wave. If you've ever been to a sporting event where the wave travels around the stadium, left to right, but each person is a particle in the wave, and each person moves up and down, up and down. So the people are the particles, and they move perpendicular to the left to right wave because they're going up and down. So there's your transverse wave. Your other example, your other type of wave, is a longitudinal wave. Copy down the title, and I'll pause real quick and let you copy the picture. Alright, now I'll explain the picture to you. So here's our slinky coil. Alright, and the way to make a longitudinal wave is where you see that the slinky compresses and then stretches. Alright? Compresses and stretches. Alright, so these spots right here, you can make an arrow and it looks like that. That's a compression. And then that's a stretch. Compression, stretch, compression. And that pattern repeats itself. Okay, so each slinky coil, if you were to grab one of the coils and just focus in on that, the coil would move left and right, all right? Not up and down like a transverse wave. Each coil would move left to right, which is the same as the direction, or parallel to the direction that the wave moves. So the particles move left and right, in and out, while the wave moves from the left to the right. So in a transverse, the particles move up and down, while the wave moves left to right. But in longitudinal, the particles move in the same direction as the wave, all right? So we're going to say that it like this. The particles, which is the slinky coils, move parallel to the wave. Parallel is that sign, it means in the same direction as. So the way to do that is, instead of moving your hand up and down on the slinky, which makes the transverse wave, our previous example, that makes the slinky go up and down while the wave goes out, we're going to push our hand in and out on the slinky like a speaker pushing on the air, okay? So we're going to push in and out, and it makes the slinky compress and stretch, and the in and out movement makes each coil, the particles, do an in and out motion as well, instead of an up and down motion, okay? A great example of this, since I mentioned a speaker, is sound waves. If instead of slinky coils in a sound wave, you have air molecules. And my vocal cords right now are pushing air molecules like this, in and out, in and out, in and out, in and out. And it makes the air molecules do a left and right motion, just like a pendulum does. That's why we talked about a pendulum last unit, because the way a pendulum moves in and out is the exact same way that an air molecule moves when we speak. It's like a slinky coil going in and out, in and out, in and out. All right? It's not that the air molecule will travel all the way to the other side. And the slinky coil is not doing that to the end of the slinky. When they go in, they go back out, just like a pendulum does, okay?